I wanted to cover a few things about strings that are important that may not be referenced as much as it should be in the content for Chapter 1 and 2, but things that are important that you will see, particularly on tests and so on. So we know that we can declare variables by putting the data type and then putting a space, giving it a name, and we can also initialize or set the value for that variable in the same line of code by putting a single equal sign for assignment and then putting the value we wish to store in that variable. And of course it'll get stored in the RAM in the memory of the computer so we can manipulate it as we see fit. So I have set up a string variable. Now this is different than an int or a double in that when I want to assign a value to a string, I have to use double quotes to surround the characters that I want to be stored in there. That flags the compiler that this is a string literal, meaning I want the exact characters that I have specified stored in memory. And I can store letters, numbers, symbols, anything between the double quotes. I could even put 1, 2, 3 in there if I wanted to. But anything between the double quotes gets considered a string of characters and it gets stored in this string variable. Now with ints and doubles we do not use the double quotes. So what I want to show you is that I can assign a value to a string with a single equal sign. I think I misspoke in one of my earlier lectures where I said we would do that differently, but we're not. We're going to use the equal sign even for strings, just like for ints and doubles, to do assignment. Now I want to show you, I'm going to print out what is in the captain variable, and when I print that out I get exactly what I gave it, capital K, little I, R, K. I get back the exact string literal, the text that I put in the double quotes comes back to me. Now with strings we have a couple of nice little optional features we can use. Say that I want to convert the entire string that the person just entered to all uppercase letters. I can do that using dot notation. I can take the variable name and stick a dot after it. No space, just a dot. And I will be given, in NetBeans at least, help by it showing me everything that I can do to that string. And so I will leave these for some other time. Not all of these are on the AP exam. But I can use this first to uppercase, and that will, just for output purposes, it will not change what is stored in memory. But in the output line, in the print line, it will give us everything in uppercase. And I can do the same thing with to lowercase. I can put the variable name, the string variable name, now this is just for strings, captain, and I can look for to lowercase, which is right there. I can double click it, it'll fill it in for me. And that will turn it into, just for printing purposes, it has not changed K-I-R-K in memory with the capital K, but just for display purposes in the print line it converts it all to lowercase. Now here I'm just proving to you that the value stored in memory has not been changed. It is still capital K, little I-R-K. These two upper and two lower, basically in the print line they change the appearance of the output, but they are not changing or manipulating the value in memory. It is still what I originally typed in. Now if I wanted to, I could create a new variable, and I'm going to call it captain UC for captain uppercase, and I can say take the Kirk that's stored in there, convert it all to uppercase, and then assign it to this new variable, captain UC. Now that one actually stores Kirk just as if I had typed in that, okay? So that one actually does have stored in it capital K-I-R-K, but the original variable, if I print it out again, you're going to see the original captain is still capital K, little I, R, K. So these 2 upper and 2 lower are, they will manipulate the output, the appearance in the print line, or if I want to save that into a new variable, I can. But this 2 uppercase is not changing the value that's stored in Captain in physical memory. It's not going to the memory and overriding it with all capital letters. It's merely just temporarily manipulating what's in Kirk, and it's allowing you to save it in another variable. Now the new variable does have it saved in all uppercase, but the original is left alone. So that's one trick with the 2 upper and 2 lower. The other thing that I wanted to show you is if I got confused and for some reason I typed Kirk without the double quotes, I'm going to get an error, cannot find symbol. In other words, it knows something is off. This is a string and it expects the value to be in double quotes. So I'm going to get an error until I do that. Similarly, if I got confused and thought it was an integer and tried to assign it an integer value, I'm going to get incompatible type. So I have to remember and use double quotes. Do not use single quotes. So if you use single quotes, you're still going to get an error. It says that's a single quotes designate a char, which is not part of the AP subset. We're not worried about that, but it's telling you this isn't a char, it's got more than one character. So you need to make sure that that's in double quotes. So notice I did not have to do any imports or anything extra to use the string. String is a capital S. I've got my variable name, I've initialized and declared it, and I can change the appearance of how it prints on the print line, and I can take it and convert it to upper to lowercase, and I can do that, and I can I can create a new variable to hold it, but putting 2 upper and 2 lower onto Captain does not change the value that was originally stored in this first string variable. I would have to create a new variable to hold the manipulated version. So I know that's something you have to kind of wrap your mind around a little bit there. We're going to do other things with strings going forward, but that's just a good thing for you to see how 2 upper and 2 lower work, because when we start comparing things for equality to see if one string equals another, KIRK with a capital K and the rest lowercase in Java's mind is not the same as Kirk with all capital letters. So if we get to a point where we're comparing strings, 2 variables that have words in them, and one is capitalized and one is not, Java will say they're not the same word. Logically, to me, I want to know if you typed Kirk, whether it's upper, lower, mixed case. So we're going to see where 2 upper and 2 lower are going to help us get rid of case sensitivity if we want to compare 2 words, 2 strings, to see if they're the same, even if the case is different. Also, for the test, you need to keep in mind integer division. So if you're given some code and you are asked what's going to print if I do x divided by y, in this case you need to be aware that you've got 2 integers, and we're going to not necessarily get the answer we expect. We're not going to get our decimal value, we're going to get a 0, because we've got an integer divided by an integer and the answer will be in integer format. One way around that is to do something along those lines to make one of the numbers a double, and I could make both of them a double, or just one of them, either way, but I will get my answer with precision if I do that. So be very aware of that as you read code on the test as well. Other questions you might be asked are about syntax errors. So for example, If I decide I want to change the value in Captain to Picard and I accidentally write it backwards, that's going to be a problem, because we said that we always put the variable name on the left. So that is backwards. And that is a syntax error. It will not compile because you have something wrong. Leaving a semicolon off, that's another syntax error. Okay, code will not compile because you've done that. So when you're looking at code on the test, be aware of integer division, syntax errors, meaning you've left a semicolon off, you've written something incorrectly, it's not going to compile. Data type mismatch, where I'm trying to assign an integer to a string variable. Now if I want it to hold 13 and I put it in double quotes, I'm signifying that's just a string of characters. But if I'm just saying I want to store the integer 13 in its numeric form in a string, that's a problem. That's a type mismatch. Be aware that we can't leave variables uninitialized, so it knows that it doesn't have a value in there. So always make sure your variables are initialized. The other thing I'll see people do, they'll get confused and they'll think they can do a string variable dot print line for some reason, that's how you print things out. You take the string variable dot print line to print something out, and that is not correct. That is a syntax error. Print line it does allow you to print out strings of characters, but print line is in its own class. It's in the system class, and when we want to print something, we always have to use system.out.println and then reference what we want to print out in these parentheses. So that's another common mistake that I see people making. Those are some of the highlights of the test, as far as you need to know how to declare a variable, initialize a variable, understand the difference between integers, doubles, and strings, understand integer division, make sure you're familiar with the order of operations, remembering that the same order of operations that governs algebra, PEMDAS, please excuse my dear Aunt Sally, parentheses, exponents, multiplication, division, addition, subtraction, we don't change those rules for programming. We follow those long established procedures, so when you're writing a long formula in Java and you've got parentheses, division, addition, subtraction, it's going to do just like you would in algebra class. It's going to do parentheses first, multiplication and division going from left to right, then addition, subtraction going from left to right. If you have exponents in there, it would of course do parentheses exponents, but we have not yet learned how to signify an exponent yet in Java. So keep in mind you should always be doing order of operations just as you would in algebra class. Even though it's Java, you'll see something about that on the test as well. You need to be aware of what's a syntax error, something that will not let the code compile. And when you read code and see that it's not correct, you may be asked to identify syntax errors in the code, such as missing parentheses, putting the equals X on the right side instead of the left, and so on. You should also be able to read some code and figure out what it does, or if it's got an error in it and it won't work. If you have any questions as you're studying, please refer back to the Object-Oriented Life lectures. There is material on the test from those. And if you would like, you can go back and look at the new Chapter 2 lectures on variables that I have posted under Camtasia Recordings 2014 MP4 lectures. You will find those to be a good review as well.